Collagen supplementation, explosive exercise performance, and implications for sprinting. What a long episode title. Today we are bringing back Dr. Dana Liss to have her talk us through some recent research on collagen in the specific context of explosive exercise performance, and we'll discuss if this may have implications for sprinting performance, whether we're talking about cyclists engaging into sprinting or runners. I understand this is a supplement that has been previously discussed here on the podcast before by Professor Stuart Phillips and Sarah Oikawa, where we concluded that collagen supplementation was not an efficient strategy to increase muscle protein synthesis and support some aerobic training adaptations when compared to whey or alpha-lactalbumin. But today we are presenting here a very specific context within tendon stiffness and its capacity to produce force. Does collagen improve explosive exercise performance? Let's find out on this episode 38 with Dr. Dana Liss. Welcome to Fuel the Pedal podcast. Hello everyone and welcome back to another episode of Fuel the Pedal podcast. Thank you so much for tuning in, and much like with the previous 37 episodes, I am still and will probably remain as your host, Gabriel Martins, nutritionist, Portuguese, forever a fierce cycling enthusiast, trying very hard to keep this podcast alive amidst my PhD journey, hopefully closer and closer to its end. On today's episode, we are having again Dr. Dana Liss from the University of California, Davis. Some of you might be familiar with Dana after episode 31 of the podcast, where she gave us a true masterclass on the low FODMAPs diet and the gut comfort in professional cyclists. If you haven't had the opportunity to listen to it and you're interested in such topics, I would recommend you to check out episode 31. And today we are bringing back Dana Liss to talk about some emerging research she has performed and presented in a poster at this year's ACSM 2020 virtual experience. This is an area where Dana has been focusing her research for a while now as part of Professor Keith Barr's research group. And we have been talking about bringing this topic here to the podcast to present a very specific context in which collagen may prove to be useful, looking at this preliminary data. But in order not to generate confusion regarding this topic, we'll make sure to cross today's information with that of episode 8 and episode 20, where we've also talked about collagen supplementation with Professor Stuart Phillips and Sarah Oikawa, respectively. And Dana will help us clarify the difference between looking at collagen from a muscle protein synthesis perspective and from a tendon stiffness and explosive exercise performance point of view. In addition to this, since Dana is pretty much in a privileged position with one foot on the research and another foot as a performance dietitian for the World Tour cycling team Israel Startup Nation, she will be able to translate her findings to the context of this podcast. So sit tight and comfortably. Let's bring back Dana Liss to the spotlight of this episode 38, collagen supplementation, explosive exercise performance, and implications for sprinting, up next on Fuel the Pedal podcast. And she's back. Dana, it is such a pleasure to have you on Fuel the Pedal again. How have you been doing?
I've been doing great. Thank you so much for having me again. It's been awesome sort of listening to all the different podcasts you've been publishing. I guess publishing is the word, or launching. Yeah, it's been really exciting. So thanks again for having me.
Dana, it's great to have you here again for a second round, this time for a totally different topic, switching gears from the low FODMAPs diet now to collagen research and the translation to cycling that you are able to do thanks to your role as a performance dietitian for a World Tour cycling team. But I'll let you tell the listeners a bit about your background and work for those who didn't have the opportunity to listen to episode 31 regarding the use of the low FODMAPs diet with cyclists. So Dana, would you mind presenting yourself again for the listeners?
Yeah, no problem. So right now, I'm actually living in Truckee, California, so up near Lake Tahoe. But I do work at University of California, Davis, in the Department of Neurobiology, Physiology, and Behavior. So I work as a project scientist in Keith Barr's lab. So I run more the human studies. So I take a lot of the molecular and engineered ligament and cellular studies that he does, and I scale them up into humans and see what we get. And then I also work, I've kind of the other foot in the field with athletes. So I work in the NBA with two teams. So National Basketball Association with the Sacramento Kings and the Golden State Warriors. And then I also have the honor of working with a New World Tour cycling team as a nutritionist, Israel Startup Nation. That role's been a little bit odd this year just because of COVID and the inability to travel. So a lot of that work's been remote, but hopefully next year things will be back to normal.
Fantastic, Dana. It's the second time I hear you presenting yourself, and it never ceases to amaze me. How do you manage to do it all and still find time to fit in this interview in your schedule? And for that, I thank you for your time and patience. As for today's topic, I think it's important to know, how did you develop an interest in this area?
I think the interest came from it being new. Like when we started looking at this in Keith's lab around 2015, 2016, it was something new in sport nutrition. And I felt for a while sport nutrition and what we could do in the field in terms of interventions maybe was getting a little bit stagnant for me. So I was really excited that this new supplement or new dietary food, in a way, it is technically, I guess, a food, if depending on how you where you source it. Sure. It was something new, and to have the opportunity to grow that area was really exciting.
Yes, I think you could consider this a food, or at least a dietary supplement, since there are indeed dietary sources, and we're going to be diving into those later in our conversation today. And as I said before, but I will emphasize again, this is a topic that has been discussed in previous episodes on Fuel the Pedal, and for that reason, we must come back to some of the points raised by other guests so that listeners won't get confused by mixed messages. The internet is pretty much full of these already, and today we will talk about different contexts in which collagen supplementation might eventually be beneficial, and we'll try to distinguish, for example, the effects of collagen on muscle protein synthesis presented here by Sara Oikawa from that of today's talk, which is a potential effect on explosive performance, and I'm sure Dana will shed us some light on these differences while presenting her new research with collagen to see if athletes can benefit from its supplementation. So Dana, we've gone through this before with Professor Stuart Phillips and both his PhD students at the time, Sara Oikawa and Philippe Teixeira, now full-grown PhDs. My best regards to them if you are listening. And just to contextualize today's talk, Dana, and provide some basic concepts to the listeners who haven't listened to those episodes, would you mind explaining to us the basics of collagen as a molecule, its function, and also its distribution in the human body?
Yeah, absolutely. So we have a whole bunch of different types of collagenous tissues, about 27 different types of collagen-based tissues in the body, everything from skin to your ligaments, to your tendons, to the extracellular matrix of your muscle. And all of these collagen type tissues have different properties. So some will be in a way stiffer. So you'd have a ligament that might be stiffer, some that would be more flexible. So your skin, for example, would be a lot more of a flexible connective tissue. And the way that collagen is formed in the body is basically you take those amino acids, partly that you've ingested maybe in a collagen supplementation or food, and those key amino acids, glycine being the most important. It occurs in every third amino acid position in a peptide sequence in a collagen or a triple collagen. And those amino acids basically go into the Golgi, and in the Golgi, the amino acids are formed into a chain, and those chains, or alpha chains, are then formed into a triple helix. And then that form, if you can imagine, basically peptide chains and then twisted into a triple helix, are then basically spit out of the Golgi, and then the ends are chopped off. So we know that we have a C terminus and an N terminus. And that's important to know, because when we see studies that have measured blood markers of collagen synthesis, we look at P1NP or P1CP, and those are the ends chopped off. So the more collagen you make, the more of those end or terminal pieces, N or C, that are floating around in the blood. So that's an indirect marker that we use to measure collagen synthesis. So once you have that basically formation, then that enzyme lysyl oxidase, which is, that's when the vitamin C comes in. So you might have heard vitamin C is really important for collagen synthesis. Well, vitamin C is a cofactor for lysyl oxidase. And lysyl oxidase's job is to cross-link those collagen molecules into a fiber. And the form, whether it's more of a fiber or a sheath, will be dependent on, the type of collagen tissue it is in the body.
Dana, this is, after all, a nutrition-oriented podcast, and therefore we must bring, whenever possible, the nutrition side of things. And in this case, we can perfectly do that since collagen is present in some dietary sources, and perhaps it would be a good idea to go through some of them, their structural differences, and if there are some bioavailability concerns regarding its absorption in humans.
Yeah, I think it's anyone who's gone to the grocery store or a supplement store or even gone online, which all of us do now, there are so many different types of collagen products on the market now. There's collagen popcorn and collagen bars, and then of course, collagen powders and collagen mixed into all sorts of different supplements and supplement mixtures. So has become very, very popular for people to use collagen for various reasons, whether it be skin or connective tissue or other connective tissues. So the original work looked at gelatin, the original sort of work in athletes and athletes supplementing with this type of protein looked at gelatin. And gelatin is something that you'll see in Jell-O. So it's basically the protein that forms that gel-like texture. You'll see gelatin in gummies, for example. And then you'll also have hydrolyzed collagen or hydrolyzed collagen peptides, they'll be called. And the difference between those two processing is gelatin is processed with a heat process, and the collagen peptides adds another enzymatic process. So we usually think the collagen peptides tend to have more single peptides, whereas the gelatin might have more dipeptides. But a lot of this really depends on partly the processing and then also just where the actual collagen has come from, whether it's come from pork, beef, or fish. So those are the two main products we'll see on the market. And in terms of digestion, I think they're about the same. There was one study that looked at gelatin versus collagen, found that the amino acids in the hydrolyzed collagen product elevated a little bit more. We found in one study we ran that looked at P1 and P levels and amino acids in the blood 1 hour after ingestion with gelatin versus collagen, that the levels were the same. So I think there's several factors affecting that. Some is just individual variability with protein digestion and absorption. Another might be, what else you have in your stomach at that time. Another factor might be just the source and the processing. So there's a lot of little factors, but I think the differences are probably pretty negligible. But if I had the choice, I would use a hydrolyzed collagen over a gelatin. The other thing to note here is Rebecca Alcock out of Australia, alongside Louise, and I think Greg Shaw was on these papers too. They looked at a whole bunch of different collagen supplements. So they looked at gelatin, they looked at a hydrolyzed collagen, they looked at bone broth. So I know it's become quite popular for people to make their own bone broth or buy like bone broth packages. And they actually found in that study that the amino acids in the bone broth supplement that they purchased were actually really low. So I would say that some of the supplements may not have what's on the package actually in the product. So I think that's important to note. They didn't look at P1 and P levels. They just looked at amino acid levels. But I think it's important to note that all products are not created equal. And my take home there would be I'd probably use hydrolyzed collagen just for palatability, and the peptides may be more single peptides. But I think for some people, it might be easier, depending on where you live, to find gelatin in a baking aisle. So if you don't have access to collagen, gelatin is usually available in the baking aisle pretty worldwide.
Got it. So, Dana, you mentioned that collagen may come from pork, beef, or fish, and these appear to be the main dietary sources that can be used to then produce these collagen peptides. But there are vegan collagen supplements out there as well. So, since plant-based diets have been growing in popularity, and some of our listeners might be interested in hearing about vegan sources of collagen, what can you tell us about these in terms of amino acid profile? Where do they come from? And pretty much the main differences between animal and plant-derived collagen.
Yeah, perfectly well-timed question. I think it's probably one of the most frequent questions I get in this subject area. But I've also just spent quite a few hours the last few days working on a vegan meal plan for one of our NBA players. And they're very large athletes. So to just dose the protein where we need it is really interesting. It's actually quite challenging to get it in food. But anyways, with the vegan supplements or vegan collagen supplements, definitely growing in popularity. Technically, collagen or gelatin supplements are not vegan because they come from animal products. I know there's definitely a few companies that are making vegan collagen, but I haven't actually seen any that have amino acids in them. So I think there's some incorrect marketing on a lot of products. So I think if glycine is really the key amino acid that's important for collagen synthesis, and we don't totally know this yet, but it's proposed that maybe glycine is the one amino acid that's super important. I would compare that to leucine for muscle protein synthesis. So if glycine is really sort of the magic amino acid in a way, then maybe we only need to feed glycine, and that's can be made in a lab, and I guess technically would be vegan. And there is, I know Keith is in, so Keith Barr at UC Davis is working on some kind of collaboration at UC Davis with some rice geneticists creating some rice that makes collagen. I have no clue how that's done, but I know there is some work being done there, and Keith would know more about that. I think it's a little bit under wraps right now, so I haven't been privy to much of the detail, but I'd say keep an eye out in that area as well.
That would go well with the collagen popcorn.
It would.
We can be watching a movie and increasing our collagen synthesis. That would be interesting. Anyway, since we are talking about collagen bioavailability, I must bring up one of the questions I've asked Professor Stuart Phillips when he was on the podcast before, which was when we ingest collagen, whether it is from a dietary source or from a collagen peptide supplement, we are talking about digesting collagen, breaking it down into amino acids, in which the most interesting one would be glycine, as you've just mentioned. And then these amino acids, mainly glycine, are further incorporated into our own endogenous collagen tissue matrix. But the question remained as to how this might happen. So now I turn to you, Dana, to help us explain this process to our listeners as to how the body metabolizes collagen, and basically how can ingesting collagen and its amino acids translates then into an increased collagen synthesis in our own bodies.
Yeah, that's a great question. And I think with a lot of Stu and Sarah's work, it's been absolutely fantastic work. Like, Stu's lab is one of the best in the world. One thing that's really different from their work and the work we're doing is they're looking at muscle protein synthesis, and collagen proteins are really low in leucine. So we wouldn't expect to see a response in muscle, or a very low response. So they're looking at muscle, and that's why, they're not necessarily seeing the response or the muscle protein synthesis as they to the same level as they did with milk or casein. So I'd say that's to be expected, but the amino acids important for connective tissues are different than those required for muscle protein synthesis. So in terms of digestion, very similar. So we see amino acid levels peak in the blood about 60 minutes after digestion. And then the one thing that's different is once those amino acids get into circulation, tissues that are more perfused with blood, so they have more capillaries, etc. Amino acids are a lot more easier to tissues, but we know that some of our key collagen-based tissues, like ligaments and tendons, don't have as much blood perfusion. So if you think about the way that I've been taught to sort of think about it, and I'm a very visual person, so you'll have heard Keith explain this before, but the analogy I find that works really well is thinking about a sponge. And when you move your ligaments and tendons, they kind of stretch and soak up the fluid around, and there'll be nutrients in that fluid, and then they compress and sort of squeeze that water out. So a lot of the nutrients that is in the fluid around those connective tissues is important for getting those amino acids integrated into the actual collagen tissues. So think about it as a summary, think about it as a sponge. And when you're extending and contracting, you're squeezing out and pulling in water or fluid. And in that fluid is where the amino acids that are integrated into the collagen, making new collagen, are located.
Well, I think that explains pretty well the difference between looking at collagen from a muscle protein synthesis perspective in comparison to what we are talking about here, and also this sponge-like way of using nutrients that collagenous tissues such as tendons have. But again, Dana, sorry for insisting in this point, but I do want to get things clear here for the listeners who might have listened to the aforementioned episodes. And something that has been argued here was that since collagen is so widely distributed in the body, we don't know if the elevator markers of collagen synthesis referred to tendons specifically, or maybe coming from bone or other tissue. So, Dana, would you agree with this point regarding the markers used to measure collagen synthesis?
Absolutely. And I 100% agree with Stu. We don't know when we're measuring P1NP, it's a very indirect marker. And we don't know if levels that we're measuring, what percent they're coming from tendon or ligament tissue turnover versus bone. Most of it is coming from bone turnover. So I think it's important to acknowledge that. And I think what we're usually doing is saying, okay, most of this is coming from bone turnover, but we can make the assumption that a portion of this is also coming from tendon and ligaments, connective tissue turnover when we're loading in a certain way based on some of its rodent data, some of its data that's actually taken tendon biopsies and measured tracers in the tendon. So I think some of it we're extrapolating, and I would completely agree with Phil that, or Stu, I'm looking at his name on paper right now. I would completely agree with Stu that, yeah, most of it is coming from bone turnover.
So, a final note just to summarize this for the listeners. If we are looking to increase muscle protein synthesis and take advantage of that peak in leucine, whey protein would still be the most adequate supplemental form to go to, and collagen applies to a totally different purpose and context. Would this be accurate?
Absolutely. And I think one thing we don't know, and I have funding to run this study, it's just a matter of COVID regulations allowing us to get back in the lab. But we don't know if whey protein has enough glycine and proline, et cetera, to stimulate collagen synthesis the same way as a collagen supplement. So it could be that whey has enough of those amino acids to do the same job. So hopefully we'll have that study run in a year or so. Just fingers crossed we can get back into the lab soon enough. And I think one other thing to note is collagen. I've heard a lot of practitioners, giving collagen after a workout or, using collagen instead of whey protein. And I think it's important to note that collagen is a really low quality protein. If you look at the Dickus scores, that's how I pronounce it. The score for collagen is 0 because it has 0 tryptophan. So it is important to note that collagen supplements have a very targeted use and a targeted timing. And I would for sure, for overall muscle protein synthesis, overall body protein synthesis, definitely a whey protein is going to be superior.
Yeah, those were some great points to make regarding the quality score of collagen as a protein source and that hypothesis on whether whey protein will be capable of producing the same effects as hydrolyzed collagen, which is something that we've talked about here with Professor Stuart Phillips as well, and that's been on my mind since then. So really looking forward that research comparing collagen with whey protein. So now that we have the foundation of collagen metabolism and how it can be metabolized in the human body, we can now move on to some of the research on collagen supplementation that might be relevant to athletes, in particular endurance athletes. And perhaps it would be interesting to talk about the seminal research by Professor Gregory Shaw and Professor Keith Barr, and any other research that you might consider relevant, so we can then move on to talk about your own research on explosive exercise performance afterwards.
Yeah, definitely. We've spent a lot of time doing dose response work and, as research goes, had a lot of learning and trials and tribulations. But the dose response stuff that we worked on did stem from the original study by Greg and Keith. And so as a summary of that study, they basically supplemented athletes with different doses of gelatin, or healthy males. I don't know if they weren't necessarily athletes, but healthy males with 0, 5, and 15 grams of gelatin with 50 milligrams of vitamin C. And they had them dose and then jump rope an hour later. So have that loading on the connective tissue to trigger or signal collagen synthesis in the body. So they did that loading, the supplement and loading, I believe 3 times a day, and they split it up by 6 hours over 72 hours. So they looked at the dose response study over 72 hours, and they took bloods at baseline, so before supplementation, and then 4 hours after the jump rope when we would expect the P1NP levels to peak. So what they found in that study was that the 15 grams of gelatin improved P1NP levels initially, and then throughout the 72 hours, significantly more than the 5 or placebo. So the conclusion from that study was that supplementing with 15 grams improved connective tissue or collagen synthesis with loading more than the lower dose or zero dose. So from that study, what we learned from that was, N of 8. So it's still a pretty small subject pool. But that, gelatin or the amino acids in gelatin could help improve connective tissue synthesis. And that has roles in adaptation to training, injury recovery. But we didn't know how collagen worked in that regard. We didn't know if it did the same thing. And we also didn't know if collagen and gelatin or a gummy form of both were similar, because you would have seen sort of around that time frame, maybe 2017, when that study was published, a lot of recipes flying around Twitter and stuff for making gummies, making gelatin gummies. So we did one quick study that used the same sort of study design as the Shaw and Barr paper, but we didn't run it out at 72 hours. We just did 24 hours where athletes came in fasted. We did a blood draw. They had the supplement. An hour later, jump roped. And then 4 hours later, we took blood draws for P1NP levels. And we fed 15 grams of gelatin, 15 grams of collagen, and an equal dose of 7.5 and 7.5 of gelatin and collagen in a gummy, all with 50 milligrams of vitamin C versus a placebo. And what we found was that the gelatin and collagen, the amino acid levels were similar 1 hour. Sorry, we did also do amino acid levels. And the P1NP levels were about 20% increased at that 4-hour time point. But we didn't see an improvement in the placebo or in the gummy. And what we think happened with the gummy is we think we killed the vitamin C by heating it too much. So that's one thing important to know for practitioners. If you are making gummies, add the vitamin C when the mixture is a lot cooler than we did. And that was just an oversight. I know that stuff. I went to dietitian school. But yeah, we just probably overheated it. So when the athletes are fasted, they wouldn't have any circulating vitamin C. So for this type of study design, that was really important. Practically, a lot of athletes are not fasted when they take collagen. So if they're eating, a balanced diet, they should have vitamin C circulating, depending on what they've eaten. So I will jump in and just finish with the last dose response. So we did do another collagen dose response study because we still don't know the best dose of collagen or the best dose of vitamin C. So we did similar study design and did a bunch of different doses of collagen. We did 5, 10, 20, and 30. And then we did different doses of vitamin C with 0, 50, and 250. And we didn't find a difference with the vitamin C doses, but we did find that 20 grams of collagen seemed to be the best dose.
Great. So all these trials and research you've mentioned are what somehow led you at least to figure out what dose to use. But I'm curious to know, what was the rationale? I mean, what made you consider the hypothesis that supplementing with collagen could improve this very specific parameter, that is force production and explosive exercise performance?
Yeah, so I think we really needed to nail down what we thought was the best dose, because there's no sense in, giving a dose we're guessing at when you're running a pretty involved study. You don't want to make that mistake. So we did have some trials and tribulations, as I mentioned, with the dosing, but I think we figured it out towards the end, and we ran this explosive performance study. So if you're thinking about, the rationale here of why would you just assume that, taking collagen would improve explosive performance? But when you look at a lot of the training that explosive type athletes use, so we're looking at, soccer players, football players, a lot of track and field athletes, sprinters and cycling, the difference between winning and losing comes down a lot to their rate of force development. And I know that Keith has done some work with the USATF, and he showed that performance in throws events was directly related to rate of force development. So how much force you can create and how fast that force is generated. So if we look at a cyclist towards the end of a race, how fast they can generate force into their pedals and how much force they can generate basically is the difference between winning and losing. So I'm really excited to try out, some of these protocols or strategies with some of our sprinters. But when we looked at this performance study, we look at loading and we look at the type of training that athletes do that are explosive athletes. They do a lot of sort of ballistic, sort of plyometric training that really, trains the body to have more stiffer connective tissue, so that stiffer connective tissue can generate force faster. So if you have a really, and I think maybe more girls will relate to this, if you have a hair elastic you've used a long time and it's all stretched out, it doesn't really wrap around your hair very well. It kind of falls out, so it doesn't work as well. But you have a brand new hair elastic, it's super tight and springy and it holds your ponytail up. So I kind of think about it like that. So we simulated what athletes usually do in training. So we took different cohorts of more explosive athletes. So we had rugby players, football players, and then we had reserve officer training corps. So an army group, sort of an elite army training group at UC Davis. And we ran the study in cohorts, because you can imagine having 50 subjects over 3 weeks, you're never going to get anyone doing the same training. So we really needed to try to get everyone to do very similar training. So over 3 weeks, subjects followed their normal team training plan, which was progressive in the manner that we needed for the study. And we overlaid a more explosive or ballistic style training program onto that. And it wasn't a lot of load. It was just, adding maybe 5 to 15 minutes more of explosive type training, like box jumps, or changing the speed of their squat. So lowering the weight, but getting to do their squat in a very explosive, quick manner. So each team had a similar explosive power-based training program overlaid on top of their normal training program. And then they took a collagen supplement. So they either had the intervention or the placebo in a parallel manner. And they took that an hour before their prescribed training from the study. And if they didn't do that training that day, because it was only done 3 days a week, and they did their normal team training, they took the supplement an hour before that. And then on rest days, we just got them to take it with breakfast. And the reason for that, it was just easier to get them to take it every day than try to remind them which days to take it. So they took the supplement and they came in the same time of day, same day each week, and they did performance testing. So we had force plates and squat rack set up, and we tested a max ISO squat. So if you can imagine that, it's basically we have a bar set up to 90% of that athlete's max bar height, ratchet strapped down as tight as you can, and we definitely learned how to use ratchet straps by the end. At the beginning of the study, I was YouTubing how to use ratchet straps. I got it dialed now. So super tight, and the athletes go in this like high squat position, and they just push up as hard and as fast as they can into the bar. And the force plate basically picks up the data. And then we did a counter movement jump and a squat jump and looked at a bunch of mechanical parameters with those jumps. And Matt Jordan from the Canadian Sport Institute, Calgary, was key in helping us with a lot of the data work related to that, and just looking at, different analysis pieces and different questions we should ask. And we found at the end of this study, we found that our primary measure, which was the rate of force development in the max ISO squat, and if you can remember, I mentioned that rate of force development is directly related to explosive performance. We found that in the hydrolyzed collagen group, so the intervention group, it improved significantly more than the intervention group. So the two sort of ways we looked at this data was we looked over time, and we saw that both groups on each testing day from baseline to 1 to 2 kind of dropped down a bit, but then the intervention group returned up to baseline, whereas the placebo group remained low. But then when we also look at change from baseline, and remembering that we want both groups to be the same at baseline. So it's hard to pull out significance when you're looking at the full timeline. But when we look at the delta change, we found a significant improvement in the collagen group. So that was really exciting, because I actually didn't think we'd see anything. That type of data has a lot of variability. So it was, exciting to see that our primary measure did show significance. Yeah. We also looked at a few other, measures of rate of force development in the counter movement jump and squat jump. And we found that the more dynamic components of the counter movement jump For example, eccentric impulse, we did find a strong trend for the intervention group improving over the placebo group. And we think that that was partly influenced by improvements in limb stiffness, because we did see a significant improvement in the delta change in limb stiffness for the collagen group compared to placebo.
And what about squat jump? Did you see anything?
No, we didn't see anything in the squat jump, so that's fine. But yeah, we did see some measures of mechanical performance that were significantly improved. And again, as I said, really excited to see if we can translate some of that with the appropriate training into our sprinters.
Yeah, that would be great. Thanks for that thorough explanation, Dana. I would just perhaps try to summarize things to help digest this info a bit more. So the rate of force development, henceforth, RFD, is a measure of explosive strength, or simply how fast an athlete can develop force, hence the rate of force development terminology. And this is defined as the speed at which the contractile elements of the muscle can develop force. Therefore, improving an athlete's RFD may make them more explosive, as they can develop larger forces in a shorter period of time. Developing a more explosive athlete may improve their performance, and there is data showing that athletes with a higher RFD have a better jumping capacity, better sprinting, and better cycling sprinting performance. So if we can increase RFD in our sprinting cyclists using this strategy, this could theoretically translate into increased sprinting capacity in such sprinting specialists. So looking forward to see perhaps some Wingate tests to prove this idea. And also, Dana, there is something I wanted to ask you that I noted after analyzing the data you sent me. So there were 2 super responder individuals, which is something that you clearly highlight there, but also the fact that there were many different individual responses to collagen supplementation observed. So is there any possible explanation in the factors that may condition a subject's response to supplementation that should be considered?
Yeah, I think one thing to note is, we did have 2 super responders, and I mentioned that in our presentations in our paper, and that if you include those data points, it pulls up the significance quite a bit. If we remove those data points, the significance lowers, but a couple of the measures are still significant, or they're very borderline. So I think that's important to note. Now, with those super responders, I mean, I could make a lot of guesses of why they were super responders. It could be that those 2 athletes we are using collegiate athletes. So I think it's important to note that maybe they had just really never been exposed to that sort of explosive training before, and they really responded really well to it. You sort of have that huge response compared to the rest of the athletes that maybe had been more conditioned to that type of training. It could have been they just had a really big learning curve with the exercises, even though we did, the familiarization and everything. They just might have had a really big learning curve, and it wasn't necessarily true performance outcomes. So I think, those are all possibilities, but, the rest of the data looked pretty tight. So when we did the deltas, so I think that's promising. So this could be, or they could just be super responders and they responded really well to the training and the supplement. And that's quite possible as well.
Yeah, makes sense. It could be a response to whether the explosive training itself, and that's something we've seen in subjects in our lab as well, or it may be a super response to the supplementation, or a mix of both. But it's good to know that most of the data retained its significance. So from what you've told us, data surely looks promising, and I know this is somewhat preliminary and needs to be further reproduced, but as you've been mentioning, do you believe that this data might be extrapolated to those cyclists who might be sprinter specialists in increasing their rate of force production towards the end of a common flat cycling stage decided through a bunch sprint?
Yeah, I think we can. And I'm excited. I think it needs to be extrapolated in a way where you have a nutritionist that understands the physiology of a training program and of the strength and conditioning program to really overlay the nutrition piece with the training. Because I think, just throwing collagen in before a sprint-based workout, it may help, but I think you also need the specific off-bike training. And I think it's important to pair those properly. And I think that in order to see some sort of improvement, if this works, it needs to be very strategically used. And it needs to be, the nutritionist working with the coach, working with the rider, working with the strength and conditioning coach to really periodize that appropriately and understand each training session and what the stimulus is to really use that well and actually possibly see an improvement. it's not something I would just throw in and say, here, take this before your rides and you'll be a better sprinter. I don't think it's going to work that way, but definitely something promising. And yeah, I'm going to push to have the opportunity to, test it out on some riders this year.
Oh, absolutely, Dana. Fantastic points to raise. Already talking a step ahead and mentioning the need for such strategies to be performed by a trained performance dietitian who understands how to implement and periodize this approach in the respective training block, that off-bike training you just made reference to. All this, of course, alongside with the coach's feedback, which is absolutely essential. And like Dr. Greg have said here on the episode dedicated to strength training in cyclists, we are still a bit afraid of lifting heavy weights and integrate this strength component, especially riders who still believe that by doing so they will increase their weight and ruin their power to weight ratio. So perhaps that is something to correct first before implementing such strategy, and only then perhaps we should worry about add-ons such as this. We surely don't want to throw the idea that you should just take collagen before your rides and be a better sprinter. We've seen that picture before and it's not what we are advocating here, so thank you, Dana, for clearing that up. And before wrapping up, there's just an additional consideration that I would throw in here, and this is something that I perhaps should refer a lot more often whenever talking about any dietary supplement here on the podcast. Would you agree that if possible, we should make sure our supplement has been third-party tested by a quality assurance program for sports nutrition products, such as Informed Sports, for example?
Yeah, absolutely. I think it's much safer. I think if you're technically, baby buying gelatin from the baking aisle, I wouldn't be too concerned. But yeah, definitely, get a third-party tested supplement. I think we need to take out any risk of having an inadvertent doping test. I know in Europe, Healthspan Elite has a collagen on the market. It's harder to find in Europe from what I've seen. It's a lot more easier to find on the shelves of most stores in North America. So yeah, definitely Informed Sport if you're a drug-tested athlete.
Well, there are a couple of other collagen supplements with Informed Sports here in Europe, actually, and it's something that I would recommend anyone to go to the Informed Sports website and just look it up before buying any other brands out there. And it's something we should apply for all supplements we buy, especially if you're an elite athlete who's often tested for banned substances. And with this, we are ready to wrap things up. And for that, I would ask you, Dana, as usual, to provide us with some take-home messages and research you would like to see performed in this area in the next 5 to 10 years.
Absolutely. So I think my take-home message would be first that, with any supplement, there may be responders and not responders. I think this field is still very young. I would say, given what we know so far in the literature and risk versus benefit, I would probably strategically integrate it into a periodized supplement plan for some riders. I think it also needs to be periodized into appropriate training program. And like you mentioned, some riders are really scared of putting on lean mass. If your program is designed optimally, you should be able to put on strength or increase strength without putting on mass. So I think that's important to understand with your trainer and as a rider too, that you can increase strength without putting on lean mass. And my other take-home messages would be to find out what's going to be your biggest gain in terms of performance. Like if you're still a developmental athlete and you still have a lot to gain just from training and getting racing experience, that might be your biggest wins right now. So I would avoid, jumping on every supplement and every strategy until you're ready for that.
That's a solid take-home message that could apply to the decision tree one should consider before deciding to take any dietary supplement. So Dana, if people want to connect with you or get in touch, where shall listeners go to?
Yeah, I do have an Instagram and Twitter account. Most people will probably be a little bit disappointed because it's mostly pictures of my son rock climbing. But I do sometimes post some nutrition stuff there. Twitter, I think it's DListForest, and Instagram is DanaList3101. And I do have a website too. It's Summit Sports Nutrition. So yeah, I've encouraged people to reach out. I think it's great to have discussions. Some of the best research questions, come from riders themselves. So I do encourage you to reach out. Feel free to debate, discuss. It's always fun to meet with practitioners worldwide.
And I will, as always, include those links on the show notes of this episode. I really like your website, Dana. I think I said this in the other episode too. But I really like your website, and I invite
thank
listeners. I invite listeners to check it out. And I hope you've enjoyed being on the podcast again.
It's always great to connect with you. We always have great chats. We get around to the podcast eventually, but we usually chat for 45 minutes.
Yeah. And this one was no exception, so you must be pretty tired of me already. Dana, please go back to your family. Thank you so much for your time, and I hope we can chat soon.
Awesome. Thanks so much for having me.
And we are done. Thank you so much for listening until the very end of this episode, and I hope you got some interesting notes regarding this emerging topic, and I'm really looking forward to see more research in this particular area. With this, I bid you farewell and hope to have you here again for a brand new episode of Fuel the Battle podcast. Take care. I am Gabriel Martins, over and out.